Paul Stamets' work on mushrooms, mushroom mycelium, and how he believes that mushroom mycelium can in fact help us save the world. And certainly he's already in the process of showing us how mushroom mycelium can change the world and the way that we look at the world. Why don't we get started by you telling us about the role of mushrooms in human history? Now, I know you could probably talk an entire interview about that, but just give people a general idea of the role mushrooms have played in history.
Well, much of this has recently come to light because of the concentration on the fossil records. And I'd like to go way back in time to give people sort of the history of life in the universe, at least as far as we know it. 13.8 billion years ago, there was a Big Bang. We all know about that. And then the Earth coalesced out of stardust around 4.5 billion years ago. The first organisms appeared in the ocean, but the first organisms that came onto land were fungi. They appeared onto land about 1.3 billion years ago. They marched onto land, and plants followed 600 million years later. And so fungi munch rocks. They produce acids and enzymes that mineralize rocks. They take calcium and manganese and iron out of the rock's mantle, and in doing so, crumble it. And so these are the vanguard species that enter into habitats, and then other organisms follow. Now, we have a more common ancestry with fungi than we do with any other kingdom. Actually, fungi are our ancestors. We split from fungi 600 million years ago. In the Journal of Eukaryotic Microbiology, a new superkingdom was proposed. I think 25 eukaryotic microbiologists co-authored this paper, and they proposed Opisthokonta as the new superkingdom, joining Animalia and fungi together. We are animals, of course, and we respire carbon dioxide, so do fungi. Fungi inhale oxygen, just like we do. We have lots of other similarities. And as we split from fungi went underground, so to speak, and we went overground. We digest our nutrients internally, and we have specialized organs like lungs and brains and stomachs. When the fungi went underground, they produced this filamentous mat called mycelium, and these are very fine, thin, thread-like cells that form networks. And these networks are very interesting because the mycelium digests its nutrients externally and then draws in those nutrients that it needs through its cell walls. But these cell walls are very thin, but the mycelium is pervasive in most all soils. There's up to 8 miles of mycelium in a single cubic inch. And the largest organism in the world is the mycelial mat, thus far known, in eastern Oregon, over 2,000 acres in size, and yet it's one cell wall thick. Now, we have 5 or 6 skin layers that protect us from infection. The mycelium has one, and it's surrounded by all sorts of millions of hungry microbes that want to consume it because it is so nutritious. How is it the largest organism in the world can be one cell wall thick? And these are highly evolved organisms, and these mycelial mats are in constant biomolecular communication with the ecosphere, and they can articulate their defenses, custom specific to the antagonists that they encounter. So the mycelium serves as lungs because it's respiring CO2 and inhaling oxygen. It is an externalized stomach because it's digesting its nutrients outside of its cellular network and drawing in the nutrients that it needs. And I propose that these are neurobiological landscapes and that mycelium, I know, is sentient. And I have a deep belief that mycelium is inherently intelligent. And these vast neuromycological networks pervade all ecosystems, and they really are the foundation of the food web. Life has emerged off of roughly 6 inches of soil. And the fungi are the grand molecular disassemblers in nature, and they give rise to plant and animal communities through the soil matrix that they are creating. So this is a foundational platform of life, and fungi break down rocks, create soil, recycle plant and animal after they die, and in doing so, humus is created. So that kind of gives you a rough idea about how fungi have entered into the landscape. But what really has steered evolution and symbiosis with fungi, to the best of our knowledge, is two cataclysmic events. There was an asteroid impact on Earth 250 million years ago. And when the asteroid hit the Earth, there was a huge amount of debris was jettisoned into the atmosphere. The skies darkened with dust. Light was choked off. And over 90% of the species, this is at the border of the Permian and the Triassic period, became extinct. And this massive loss of species obviously fueled lots of debris fields, and the fungi surged, and fungi inherited the Earth. Those organisms that paired with fungi, since fungi do not require light, then benefited, and through natural selection, they were favored, and they surged to the forefront. Now, species diversification occurred, and we marched forward to 65 million years ago, and bam, we get hit by another asteroid. There's a recurring theme here, folks. And the same thing happened. The skies were darkened, light was shut off, and fungi re-inherited the Earth. Through these two cataclysmic asteroid events, pairing with fungi was rewarded. And so those organisms, animals, insects, and plants that pair with fungi had an added advantage in terms of gathering nutrients and being able to survive these long periods of darkness. Now, there's other factors, of course, that have rewarded symbiosis, but this is just two examples. In the Journal of Geology 2 months ago, there was an excellent article that was produced speaking to a fossil group that's been a mystery for over 150 years. And around 1850, I think the first fossil of Prototaxides was found in Saudi Arabia. And they've also found these fossils in Quebec and elsewhere. I think there's several dozen of these fossils have been found. And according to the geological record, they existed 420 million years ago. 420 million years ago, the tallest plants on Earth were under 2 feet tall. And yet this Prototaxides, which scientists now believe is a mushroom, stood 30 feet tall and was 4 feet in diameter. So 420 million years ago, the tallest organisms on the planet of Earth were these giant mushrooms. And then plants ascended. We don't know why these things don't exist today, but 99% of the species that have ever existed are now extinct. And that's an interesting concept, that we're less than 1% of the species that we see today is of all the species that have ever existed. But we march forward, and the oldest mushrooms found in amber is 100 million years old. Now, if you go back 100 million years ago and you walk through the forest and you saw mushrooms, you would recognize them. But if you looked around for something that looked like a human, there would be nothing in your viewscape or on Earth that even resembled hominids whatsoever. Mushrooms had their form long before we had ours. And there's a form of biological racism, unfortunately, that I've been confronting all of my life. And people are prejudiced against mushrooms. You say mushrooms, and people think portobellos are magic mushrooms. But very few people have any clue that we evolved from fungi, and fungi are our ancestors. And understanding how they emerge through these landscapes and how they have a mothering influence to the benefit of the ecological community becomes a big surprise to those who are not familiar with this subject. It's an extremely exciting field right now, because through the theater of evolution, there's been, more than 1 billion years of experiments in nature that I think we can benefit from. And that's what I'm really focused on, is looking at that which nature has already invented and seeing how we can apply it or cross-apply it to some of the catastrophia that humans are committing today.
So let's fast forward a little bit and talk about the emergence of civilizations, the formation of communities. How have people interacted with mushrooms, and how have mushrooms shaped the course of history?
Excellent question. The famous Iceman that was found in the fall of, I believe, 1991 on the border of Austria and Italy is the best preserved remains of a human so far found in a quote-unquote natural setting, which means he wasn't buried. And he apparently died from an infection from an arrowhead in his back. And the Iceman had with him 2 polypore mushrooms. Now, these are wood shelf conch mushrooms. They're in the shape of a hoof, and they often are mostly are attached to trees. And one mushroom that he had in particular has been known throughout the ages as amadou. And amadou is the Latin name for the mushroom is Fomes fomentarius. It's a birch polypore. So they are very common in birch forests throughout the world. And this mushroom is a fire starter mushroom. You can hollow this mushroom out, put embers of a fire in it, and keep fire alive for days. This literally allowed and helped the migration of humans out of Africa into Europe. Because when we moved out of Africa into Europe, we discovered something new called winter. And oops, and if you didn't have fire, your clan would die. And so having the portability of fire enabled human migration and to keep fire alive. And the firekeeper of any clan, of course, historically has been an extremely important role. So this wood conch, when you boil it in water and you pound it, it separates into the fibers which are mycelium. And when you pound this mushroom after you boil it in water, it separates into a fabric. And this fabric is highly flammable. And it also revolutionized warfare because this is literally the punk that enabled flint spark rifles to work, because the spark would fall onto this mycelial fabric, which is highly flammable. It would then burn, and then it would ignite the gunpowder. So this mushroom also revolutionized warfare, and of course any clan or tribe or group that had these weapons versus a tribe that did not would have a strong competitive advantage. There's dozens of examples such as this, but mushrooms have played a pivotal role. And 10,000 years ago, we were forest people. We were in intimate contact with nature. We were dependent upon the forest ecosystems. Our body intellect of knowledge of fungi in the ecosystem, I think 10,000 years ago, exceeds, from a practical point of view, the knowledge that we have today.
So could you talk a little bit about when people started cultivating mushrooms? What species did they start cultivating? How was it done, and where did this occur?
The first species, well, being woods people, we would gather wood for fires. And so it's hard to say when this was first noticed, but no doubt in my mind it goes back hundreds of thousands of years, in that when you collect firewood, and this is seen today, and you have it by your house, and if it gets wet, mushrooms sprout from the wood. Well, in Asia, the shiitake mushroom was first discovered. It's interesting. The Chinese say that they discovered it. The Koreans say that they discovered it. The Japanese say that they discovered it, that you could grow shiitake mushrooms on wood. No doubt there's a common truth amongst the three claims. And a wood gathering people would notice that these very, very, very delicious shiitake mushrooms would fruit on the wood that they gathered. And they also realized if you took freshly cut wood and you put it in between the logs or limbs that were producing the shiitake, the spore cast from the mushrooms, drifting a few inches, would land on the adjacent log, and then those logs would become infected or inoculated, and then that way they could perpetually keep the shiitake mushrooms in culture. In Europe, the cultivation of button mushrooms really was pioneered in France, and it was one of the gardeners of one of the kings. I think it's King Louis XIV, and I have to go back to my notes to check on that. And realizing that the mushrooms were growing in horse paddocks, and then looking for a moist, constant temperature-controlled environments, there was a nearby cave, and compost was taken down into the cave, and it turned out to be a wonderful environment to grow mushrooms. And so these are the vanguard species that enter into habitats, and then other organisms follow. Now, we have a more common ancestry with fungi than we do with any other kingdom. Actually, fungi are our ancestors. We split from fungi 600 million.
Talk an entire interview about that, but just give people a general idea of the role mushrooms have played in history.
Well, much of this has recently come to light because of the concentration on the fossil records. And I'd like to go way back in time to give people sort of the history of life in the universe, at least as far as we know it.
Paul Stamets' work on mushrooms, mushroom mycelium, and how he believes that mushroom mycelium can in fact help us save the world. And certainly he's already in the process of showing us how mushroom mycelium can change the world and the way that we look at the world. Why don't we get started by you telling us about the role of mushrooms in human history? Now, I know you could probably...
13.8 billion years ago, there was a Big Bang. We all know about that. And then the Earth coalesced out of stardust around 4.5 billion years ago. The first organisms appeared in the ocean, but the first organisms that came onto land were fungi. They appeared onto land about 1.3 billion years ago. They marched onto land, and plants followed 600 million years later. And so fungi munch rocks. They produce acids and enzymes that mineralize rocks. They take calcium and manganese and iron out of the rock mantle, and in doing so crumble it.